Today, we are going to tell you about Newton and his first law, so buckle up, because we're about to take a journey into the very foundation of how everything in the universe moves. You might think, oh, physics, that sounds complicated, but stick with me, because this one law explains so many things you see every day, from why you feel pushed back in your seat when a car speeds up, to why a soccer ball eventually stops rolling. It's called the Law of Inertia, and honestly, it's one of the most fundamental rules of reality. Before Sir Isaac Newton came along in the 17th century, people had some pretty strange ideas about motion. They thought that the natural state of any object was to be at rest, and that you needed to constantly push or pull something to keep it moving. It kind of makes sense, right? If you stop pedaling your bike, you slow down and stop. If you stop pushing a box across the floor, it stops. But Newton, with his brilliant mind, realized something crucial. He saw that things don't stop on their own. They stop because of an invisible force acting on them. In the case of your bike or the box, that force is friction. Friction from the ground, friction from the air, it's everywhere, constantly trying to slow things down. So, Newton asked a revolutionary question. What would happen if there were no friction? What if there were no forces at all acting on an object? And that's where his first law of motion comes in. It has two parts, and both are equally important. The first part states, an object at rest will stay at rest unless acted upon by an external force. This is pretty intuitive. Your coffee mug isn't going to just randomly fly off the table. My laptop won't suddenly slide away. They will stay put, perfectly still, forever, unless something like my hand, or an earthquake, or a very curious cat comes along and pushes or pulls them. The natural tendency of an object at rest is to just keep on resting. That laziness, that resistance to change, is called inertia. Now for the second, and arguably more mind-blowing part, an object in motion will stay in motion, with the same speed and in the same direction, unless acted upon by an external force. This is the one that's harder to see in our daily lives because of that pesky force, friction. But imagine you're in the vast emptiness of outer space. If you take a wrench and throw it, what happens? There's no air resistance, no gravity to pull it down, no friction. That wrench will continue to travel in a straight line at the exact same speed you threw it, forever and ever. Or at least until it crashes into a planet or a star millions of years from now. It won't slow down. It won't speed up. It won't turn. Its motion will remain constant. That resistance to changing its state of motion is also inertia. An object that is moving wants to keep moving. An object that is still wants to stay still. Inertia is basically an object's stubbornness. And here's a key point. The more mass an object has, the more inertia it has. It's much harder to push a massive boulder into motion than a small pebble. It's also much harder to stop a moving freight train than a moving bicycle. The train has vastly more mass, and therefore, more inertia, more resistance to changing its state of motion. Let's bring this back down to earth with some examples you've definitely experienced. Think about being in a car. When the driver suddenly hits the gas, what happens? You feel like you're being pushed back into your seat, but you're not actually being pushed back. Your body, because of its inertia, is trying to stay at rest, right where it was. The car is moving forward underneath you, and the seat is literally pushing your back forward to make you accelerate with the car. Now, what happens when the driver slams on the brakes? You lurch forward. Why? Because your body, which was moving at the same speed as the car, wants to keep moving forward due to inertia. The car is slowing down, but your body is trying to continue at its original speed. Thank goodness for seatbelts. A seatbelt is the external force that acts on your body to slow you down along with the car, preventing you from continuing your forward motion right into the dashboard. Here's another one. Have you ever seen that classic magic trick where a tablecloth is whipped out from under a full set of dishes? That's not magic. It's Newton's first law. The dishes have inertia. They are at rest and want to stay at rest. If you pull the tablecloth fast enough, the force of friction acts on the dishes for such a short time that it's not enough to overcome their inertia and get them moving. So, they stay put while the tablecloth zips out from underneath them. Don't try this at home with your good china though. It takes a lot of practice to do it just right. This law is everywhere. When you shake a wet towel, you're using inertia. You move the towel quickly in one direction and then stop it abruptly. The water droplets, however, want to keep moving because of their inertia, so they fly off the towel. When a football player runs with the ball, it's much harder for a defender to change their direction than it is for a smaller, lighter player. The bigger player has more mass, more inertia, and a greater resistance to changing their path. So, who was the man behind this groundbreaking law? Sir Isaac Newton was an English mathematician, physicist, astronomer, and theologian who lived from 1643 to 1727. He is widely recognized as one of the most influential scientists of all time. His book, Philosophiae Naturalis Principia Mathematica, or Principia for short, published in 1687, laid the foundations for classical mechanics. In this single work, he didn't just give us the first law, but also his second and third laws of motion, and the law of universal gravitation. These laws completely revolutionized our understanding of the cosmos. They explained why planets orbit the sun, why the moon causes tides, and why an apple falls from a tree, the very story that supposedly inspired his thoughts on gravity. It's important to note, however, that Newton stood on the shoulders of giants. Scientists like Galileo Galilei had already done experiments and developed the concept of inertia before Newton. Galileo was one of the first to challenge the old ideas and suggest that an object in motion would stay in motion without a force. But it was Newton who refined this idea, formalized it as his first law, and placed it within a complete, mathematical framework of motion that could be used to make precise predictions. Newton's first law essentially defines what a force is. If an object's motion is changing, meaning it's speeding up, slowing down, or changing direction, then you know a net force must be acting on it. If its motion is constant, which includes being at rest, then the net force on it is zero. This might mean there are no forces at all, or it could mean that all the forces acting on it are perfectly balanced, canceling each other out. Think about a book resting on a table. Is there a force on it? Yes, gravity is pulling it down, but the book isn't accelerating through the floor. Why not? Because the table is pushing up with an equal and opposite force. The forces are balanced. The net force is zero, and so the book's state of motion, being at rest, doesn't change. Perfectly in line with the first law. The same is true for a car driving at a perfectly steady 60 miles per hour on a straight highway. The engine is pushing the car forward, but air resistance and road friction are pushing it backward. At a constant speed, these forces are balanced. The net force is zero, and the car's motion remains constant. It's only when the driver pushes the accelerator, increasing the forward force, or hits the brakes, increasing the backward force, that the net force becomes non-zero and the car's velocity changes. So, to recap, Newton's first law, the law of inertia, tells us that objects are stubborn. They resist changes in their motion. If they're at rest, they want to stay at rest. If they're moving, they want to keep moving in a straight line at a constant speed. A change in motion only happens when an unbalanced, external force comes along to shake things up. The amount of this stubbornness, or inertia, depends directly on the object's mass. This simple but profound law changed science forever. It wiped away centuries of incorrect thinking and gave us a clear, accurate starting point for understanding all motion, from the smallest particles to the largest galaxies. It's the rule that governs your every move and the motion of everything around you. I hope this has given you a new appreciation for the physics hidden in plain sight. The next time you're in a vehicle or see a ball roll to a stop, you'll know exactly why it's happening. Thanks so much for watching. If you found this video helpful and want to learn more about the amazing world of science, don't forget to hit that like button, subscribe to the channel, and ring the notification bell so you never miss an update. See you in the next video.